The format is going to be X and Y on the same side, right? A, B, and C are going to be numbers. So it says, a local museum, it has a special bug exhibit. Ew. Adult tickets are $11. Okay, that's probably important. And child tickets are $5. Okay, we spent a total of $55 on tickets. X is the number of child. This is important, right? So I'm going to put an X over here. And Y is adults. So I'm going to put a Y here. Because sometimes the way they write this, if the first one is not always X. So you really need to pay attention to that labeling that they tell us. Write a function to represent the situation. So this is more real life. Maybe you don't go to a museum. Maybe you're going to the movie theater, right? Where tickets cost different amounts. So tell me about the child tickets. How would we represent the child tickets? 5X, very nice. And what about the adult tickets? And 11Y. And it's going to be a plus because total means we're adding. And how much money did we spend? 55. So standard form is going to be very real world. Like those word problems are actually going to make sense. And you're like, oh, I could see that actually happening. There are some very special rules for standard form. So there's your format again. In standard form, A, B, and C are numbers. They're integers, right? They could be positive or negative. Whole numbers. That's the key. Whose greatest common factor is 1, meaning they cannot be simplified. If it was 2, 4, and 6, we could simplify all of those by 2. Okay, so we're saying, like on the one above it, 5, 11, and 55, they don't have any factors in common. That is simplified as much as it can be. A must forever until the end of time be positive. Okay, I can't honestly tell you the reason why. I just know that it is. A and B cannot both be 0. You can have one of them be 0, but not both. So based on those definitions, which of these would we circle that are correctly in standard form? Which one do you think? What's correctly in standard form? 7x plus 3y, okay. 3x plus 4y. 2x plus 5y. And what about the others? Is negative 5x going to work? No. So this is not because that A is negative. What about the 3/4? Is that one right? No. Has to be an integer, meaning a positive or a negative whole number. There are no fractions or decimals in standard form. What about this other one, y minus 3? That's the one we just did. That's point slope, so that's not even correct. So the nice thing about standard form is that if we want to graph, we do not necessarily have to change to y equals mx plus b. We don't have to move our ax and divide by our y like we did in Unit 1. We can graph by something called the x and y intercepts. Now, I'm going to jump down here real quick. I want you to realize that on an x-intercept, the number is where the x is and the y is a 0. And on the y-intercept, the x is 0. And the b or the y is where the number is. So if it's an x-intercept, there's a number for x. If it's a y-intercept, there's a number for y. The intercept is the point where the graph crosses the axis, depending on the x or the y. The x-intercept, okay, this is a big vocabulary word, is also called a 0. Super, super important there. The x-intercept is also called a 0. It has some other numbers, but right now we're going to stick with 0 and we'll add some later. And it's the point where we cross the x-axis. Okay? The x-intercept will always have a y value of 0, and the y-intercept will always have an x value of 0. So again, if it's an x-intercept, we have a number for the x. If it's a y-intercept, we have a number for the y. So if you look over here at this graph, I'm going to go ahead and make it big. I have a y-intercept of 0, 6. and I have an x-intercept of a 0. What's another word for x-intercept? 0. Find the x and y intercept of the function, and then we're going to graph it. All right, so let's put a 1 right here. This is also known as the cover-up method. So think about this. On the x-intercept, the y is 0. On the y-intercept, the x is 0. We are just plugging that 0 value in. So if I want to find my x-intercept, essentially what I'm doing is I'm saying 2 times 0 for my y. Well, what happens times 0? 0. This just goes away. So really, we could just cover up our y like this and solve 1x equals 6. What is 1x equals 6? X equals 6. So what is my x-intercept or my 0? 6, 0 right here. Same thing on my y-intercept. You could write it out. You could say 1 times 0 plus 2y equals 6. You could do that. Or you could just cover up with your finger. You could cover up that x. Well, what's 2y equals 6? What do? We divide by 2. Y equals 3. Now I have 2 points on my graph, and I can draw my line. So find your x and your y-intercepts. And if it helps you to like set up where the zeros are first, you can do that. So for the x-intercept, I'm essentially covering up my y. So I get 4x equals 28. So x equals 7. For my y-intercept, I'm covering up my x. 7y equals 28, y equals 4. So my graph, here's my y-intercept, 0, 4. Here's my x-intercept, my 0. And I can see I have a negative slope. So that's one way you can write a graph from standard form. The other way is what we did in Unit 1. And we take our standard form and we change it to slope-intercept. When we did this before, these were our steps. We said step 1, move AX, and AX is always positive, so we're going to end up subtracting it. And then step 2, divide the Y coefficient on everything. Okay, so this is review, and again, you can do this whichever way you prefer. So we're going to practice on these two, and then again, when you get to your whatever you're working on, you can choose. So if I'm going to move on number 3, if I'm going to move my x, how do I move a 4x? I'm going to subtract it on both sides. Now, can I put a 12 with a 4x? No. And then, so we've moved our ax. Remember, you can't put it with a constant. And then we're going to divide everything by that y coefficient. Be careful here. Y equals what? What do you know about 12 over 6? 2. What do you know about negative 4 over 6? Okay, it is negative 2/3 x. There's our equation. If you don't like it written like that, you can write y equals negative 2/3 x plus 2. That's the same thing. What's our slope? Negative 2/3. So this graph should go down. If we're going to graph it, we'll start at our b. We're going to count down 2 over 3. And there's our line. So we're going to move our x. And divide everything by 5. Y equals negative 7 over 5x plus 7. So my slope is negative 7 over 5. And I'm going to show you a trick to that in just a minute. So if we start up here at 7, down 7 over 5, there's our graph. I do want you to realize that when we change ax plus by equals c, I think do you have a little bit of space up at the top maybe? Or you can go back later and look at your bubble notes. So when we did this before, we set it up like this, right? We divided everything by b. Here's what I want you to realize. If this is y equals mx plus b, right? Or b plus mx. Your slope is always going to be change the sign of a and put it over b. So if you look down at the one we just did, number 4, right? Our a was 7. When we wrote our slope, it became a -7. Our b was 5. So our slope was -7 over 5. Your b will always be c over b. So our c was 35 on number 4, and our b was 5. 35 over 5 was 7, which was our y-intercept. If that is something that you find helpful, then do that. If you would prefer just to change it like normal, you can do that as well. So I just wanted to show you another method. Ureli is going to graph the equation 8x plus 3y equals 24. What will be this? Oh, 0. What is that word? That is your x-intercept. Yes. So that is going to be where x is 0 or y is 0?
Y is 0.
The y is 0. We are looking for the x number. So I can cover up my y. 8x equals 24. X equals 3. Okay? So make sure you're covering up the right things. All right, how are we going to figure this out? This is new. Is 3 -5 on the line? Guys, I want you to realize this is an x and this is a y, is it not? When we first did solving equations and we got an answer, did we plug that number in for the letter and see if we got a true statement? Yes. Could we do that here? Let's see. We got 8. What am I going to do for x? Can I say 8 times 3 plus 3 times what? -5 equals 24. See if that's a true statement in your calculator. It is false. So is 3 -5 on the line? No. It would have to be true. Hans paid to enter the fair where he could ride various rides. 5x minus 2y equals -30. X is the number of rides and y is the total cost. How much did each ride cost? Okay, and entrance fee. So what are we talking, if we say each, every, per, what are we talking about? We're talking about slope. So this is saying what is m, right? Each, every, per is slope. And our entrance fee, that's our beginning. So what is that? That's your b, that's your y-intercept. So what would be the best method to figure these things out? Could we change this 5x minus 2y equals -30? 2y equals mx plus b if that's what they're asking us for? Sure. How am I going to do that? Subtract the 5x. Yeah, we're going to move them over. And then divide. Now, -2. Very good. Make sure you take the sign. We don't change the sign when we divide. What do you know about a -30 divided by a -2? Positive 15. And a -5 over -2 is positive 5 over 2x. So how much was each ride? $2.50. And how much was the entrance fee? $15. That's an expensive fare. Last two. How are we going to figure out which equation represents that picture?
Which one has a y? Look at the x and the y.
You can look at your x and your y-intercept for sure. So you could use your answers to help you. Could we also do what we did this one, part B, where we plugged in the numbers to get true or false? You could. So there's a lot of ways you could do this. Could we also look at that line and write y equals mx plus b? and then change them, or I could even show you how to change y equals mx plus b to standard. So what would we like to do? So if we're going to plug in the coordinates, so for A, if you're going to plug in -6, 0, then you're saying 3 times -6 plus 2 times 0, is that -12? No. So it didn't work for the first one, so we're automatically done. If you wanted to do that method, is that what you prefer? Do we want to change anything to y equals mx plus b? It's up to you. I want you to keep working through it. So the answer is B. I went ahead and I showed a different way. I took the graph and I wrote my y equals mx plus b equation, and then on B I moved my x and I divided it, happened to be B. So you have a lot of different methods you could use to solve this, so you just pick the way that works best for you. All right, last one. Pedro has $18 to spend at the grocery store. His mom wants him to buy fruit. Apples are $2 a pound and pears are $3 a pound. If X is apples, so I'm going to put X here, and Y is pears, can we write an equation?
Yes.
What is your equation?
2x plus 3y equals 18.
2x plus 3y equals 18. He bought $2 for each pound of apples plus $3 for each pound of pears, and he had $18 total. How are you going to find this x-intercept? Cover up the y. So when I do that, what is my x? X is 9. Okay, so here's the key. What does it represent? So if I come over here to my graph and I put a dot at 9, 0, what is that saying? Remember how we talked about labels previously? So this is 9 apples and 0 pears. So 9 LBS is pounds of apples. That's a lot of apples. 0 pounds of pears. That's what that is saying. So for all $18, he only bought apples. What about the y-intercept? What are we going to replace with 0 there? We want to solve for y, right? So we're going to cover up the x. So 3y equals 18. 0, 6. Make sure you write it as a coordinate. So that's way up here. So what does that mean? 6 pounds of pears. How many pounds of apples? 0 pounds of apples. Use those to create our graph. There it is. And boom.